Welcome to a little lab rat fun, networking with fish. What we're going to talk about today is IWAN, Intelligent Wide Area Networking, Cisco's SD-WAN solution, and specifically why EIGRP or BGP over the DMVPN. A lot of people seem to think that the reason why we say to please do EIGRP or BGP over the DMVPN is because they scale well in a hub and spoke environment. That is true. They both scale very well in a hub and spoke environment as opposed to OSPF. But it's not everything. So let's talk about some of the additional coolness and magic of what Intelligent Path Control can do, which you'll then see in just a little bit. So what we're going to go ahead and do is look at the CPUC, the Customer Proof of Concept IWAN pre-built testbed, the brownfield one, not the greenfield one with the APIC EM and the IWAN app. So this is already all built. And what we're going to go ahead and do is we're going to drill in just a little bit so it doesn't get so busy. And we're going to look just at branch 3. So branch 3, and then we have an ISP cloud, an MPLS cloud, and we also have POP1, as you notice the other POP1 away, and a data center. So what we're going to go ahead and do is we're going to go ahead and talk about branch 3. Anything behind branch 3 is 10.3.0.0/16. And this little TC right here is actually a traffic generator, a Spirent traffic generator that I'm using to send traffic between branch 3 and over here up at the hub. The hub is at address 172.16.0.0/16, so my Spirent traffic generator is also that TC up there is Spirent traffic generator. This WB right here is a impairment tool. It is the WAN bridge that you can get out on just out on the web, and it actually has impairment going on. I have some impairment going on right now, coincidentally, but getting ahead of myself. Now let's talk about your environment right now. Your environment, a lot of people are running a branch with an MPLS and an internet link. And a lot of people are doing that in a primary backup type environment where your internet link, your ISP link, is only used today should the primary path fail over the MPLS. And a large amount of people right now would like the MPLS link to get used and are using the MPLS link as a primary, both from branch 3 to the hub and from the hub to branch 3. Again, with the ISP link as a backup only. Now what is starting to happen is that people are starting to look at that backup link and saying, hey, you know, look at this. I've got 1.5 meg here in both directions for my MPLS primary, but I've got 2 meg going down and 10 meg going down and 2 meg going up on my internet. I'd like to start using this, I think. I haven't really used it a lot, not too sure, but everyone says that they're getting more reliable. And so what I'd like to do is I'd like to go ahead and start using them. So let's talk about how this is going to go. Again, in your environment, you probably have a primary and a backup. In our environment, this is tunnel 10. Is the MPLS primary. It is tunnel 10 right down here from branch 3 up to the DMVPN head end up here, IWAN POP1 MPLS. And it is tunnel 20 from down here into the ISP up through the ASA and up here to IWAN-POP1-INET. I'm actually doing EIGRP in this environment, both over the DMVPN as well as up in the hub. So from that perspective, you would normally have one entry. So in branch 3, if you're doing this today from a primary and backup perspective, if you were to look at the routing table on branch 3, you would see one entry in the RIB for 172.16.0.0/16. So over here on branch 3, if we were to go into the RIB, we would have one entry in the RIB for 172.16.0.0/16. And over here in what we call the core router, or named IWAN core, we would have one entry in the RIB for 10.3.0.0/16. The entry in branch 3 would be using the primary, so it would be going up and pointing up to the other end of tunnel 10, and it would be going over to the MPLS link, and the core would actually be pointing up towards IWAN-POP1-MPLS, going out that way. Very typical that this is how people have this set up. So let's go ahead and look at that right now. And we'll go ahead and look in branch 3 and do a show IP route. And right down here we will see that we have one EIGRP entry for the hub subnet 172.16.00.16 in our RIB. We do not have the other entry over tunnel 10. However, if you will notice, show IP EIGRP neighbors, we do have two neighbors. We have an EIGRP neighbor from us, branch 3, up to the MPLS DMVPN hub 10.0.224.1. We also have an EIGRP neighbor over on 10.0.232.1 on tunnel 20. If we were to do an IP EIGRP topo table, 172.16.0.0/16, what we would actually see is that yes, we as branch 3 are getting an advertisement over the ISP link over tunnel 20 from 10.0.232.1 on how to get to the hub prefix 172.16.0.0/16. However, we are choosing the one over tunnel 10 as the best, and we are putting this one in the RIB. So again, branch 3 has one entry in the RIB. If we go up to the core router and we look on how do we get to 10.3, we can see up on the core router right here that if we want to get to 10.3, we are supposed to go to gigabit 1023. Now again, if we do a show IP EIGRP neighbor, I actually have a connection gigabit 1023 is actually my EIGRP neighbor from the core router up to the MPLS WAN hub, and gigabit 1024 is actually my connection to the internet DMVPN hub. Again, if we were to do a show IP EIGRP topo 10.3.0.0/16, what we would find is we actually are getting an advertisement from both of them, but we're only actually putting one of them in the RIB. So from that perspective, that's where we're at. But a lot of people are actually thinking, of course, we want to use that other link. So what they want to do is actually put business critical over tunnel 10 because they're already paying the money, they're already having tight SLAs, and they're already paying for those tight SLAs. And they'd like to send the non-business critical out over tunnel 20. Tunnel 20 is a bit of an unknown. There is admittedly from a lot of customers that I've seen a lot of fear, uncertainty, and doubt because it has been sitting there not doing a lot for a lot of people unless the MPLS link goes down. So as people are actually moving to intelligent path control and the IWAN solution, what I am finding is that they're not necessarily jumping to let's go ahead and get rid of that MPLS. It's more a let's put the business critical over the MPLS and let's try to move the non-business critical over to the ISP. Now, how do you do that? Intelligent Path Control, or PFR v3, is actually going to sit on top of the routing table. What do I mean by that? Well, it's a little bit confusing, right? The question is if we're going to send the business critical traffic, for example, let's say EF, AF41, AF31, so the traffic that is going to the hub 172.16.0.0/16, and we're going to say, hey, EF, AF41, and AF31, you're going to go ahead and use the MPLS. But AF11, yeah, you're going to go ahead and use the ISP. Now, how do we use tunnel 20 to get to 172.16.0.0/16 if it's not in the RIB? Well, that's pretty much what intelligent path control comes in for. So if we actually do intelligent path control, we can actually use that not only just for the business critical, the EF, the AF41, the AF31, or whatever you decide. You can, of course, also do NBAR2, network-based application recognition. Not only can you split your business critical and non-business critical, but what you can also do, of course, in keeping with intelligent decision making at the WAN edge, if there is impairment right here, and I'm actually causing 5% loss impairment right here, and I have business critical traffic, I have EF traffic that is coming in from this Spirent test center up to the switch out here, and my one policy to rule them all, which I actually defined over here on the IWAN master controller, says that a 5% loss is an impairment that I desperately would like to avoid for my business critical traffic. Move me over to the non-business critical link, the tunnel 20 link. Now, of course, with one entry in the RIB for 172.16.00.16, and that is still pointing out tunnel 10, how do I send anything out on tunnel 20 destined for 172.16.00.16? Again, the intelligent path control. Let's look at this. So we already know that at branch 3, if I were to do a show IP route, it would say that I am supposed to, according to the control plane, send 172.16.00.16 traffic out over tunnel 10. If that were the case, then please riddle me this. I'm going to hit a refresh button right now. This is live action, and this is going to tell me exactly where that EF critical traffic is going. And as you can see from branch 3, that traffic is actually going in and out of tunnel 20. It is going in and out of the internet. It is going in and out of the iNet POP head-end DMVPN. It is not going in and out of tunnel 10. In fact, it is completely staying off of tunnel 10 because the intelligent decision making at the WAN edge has realized that there is an impairment over there and we need to avoid that. So we were actually going over the internet right now, right this very second. How is this happening? How am I, from a branch 3 perspective, going in and out of tunnel 20? How is this possibly happening? We already looked at the routing table, and we saw that the routing table believes that it is supposed to be going in and out of the MPLS cloud. If we actually look back here at branch 3, we'll see a little P flag here. That little P flag says, hey, by the way, there might be an override right now. So my routing table, my routing information base tells me to go to tunnel 10. However, intelligent path control decision making may be saying that we need to go out a different way. So if we actually do a show IP route, and like you can actually do an EIGRP or an OSPF, and now you can do an overrides PFR. And we can even do a DSCP EF, which is what my traffic is. And there you go, right here, show IP route overrides PFR DSCP EF. So show IP route, and you could have done an EIGRP or whatever. So this is just a new thing that you can go ahead and get even more granular with. So what does this say? This says that in my RIB, in my routing information base, my control plane, EIGRP, from over tunnel 10 is telling me that what should be best is going out over tunnel 10. PFR may be overriding this, and this is actually going to tell me and be in sync with the PFR Intelligent Path Control code, and it's going to say, yeah, you know what? I actually have traffic that is EF traffic that is going to the hub site It's traffic class ID 11. This is its fingerprint. And right now, it is actually going out primary channel 24, backup channel 31. So it's going out primary channel 24, tunnel 10, backup channel 31, I'm so sorry, primary channel 24, primary interface tunnel 20. So it is going out tunnel 20. It is not going out tunnel 10. There's a backup channel, channel 31, and that's to go back over this one. So if we do a show domain default master traffic class, whoops-a-daisy, traffic class DSCP EF. Now I want you to remember, class ID 11, primary channel 24, backup channel 31. This is another way of looking at it. This is specifically the PFR v3, the intelligent path control, traffic class 11, traffic class 11. We are going out present channel 24, and we are going out the INET, which is right here, and our backup channel is right here. Why did we move? Well, we moved because of the fact that we were on the MPLS, and then we had to move over to the INET, and the reason was, and I'm so sorry that this goes off the screen, but the reason is that we were out of policy. We had a loss rate of 4.87. Remember, I told you I actually have impairment on that MPLS link. So we avoided it. The reason for the last change, the reason from going from MPLS to the INET, the reason why we have been on the INET for the past hour is because of the fact that we actually had loss. This is actually following a voice policy. We also could have done a summary. So a summary will actually show you right here. This is EF, again, traffic class ID 11, primary channel 24, backup channel 31. Service provider is INET. It is currently going out tunnel 20. That actually is also happening the other way around, but just focusing right here for right now. So why did we not actually change the rib? Why did Intelligent Path Control not actually put in a tunnel 20 there? Well, it didn't put it as a you want this to happen should Intelligent Path Control die. But as you see from the PFR overrides, you can actually find that information in there and where exactly your traffic is going. Let's take this one step further. Why is there only one entry in the rib? Well, let me ask you a question. If something were to happen, that the Intelligent Path Control died, for example, there was a problem up at the head end, borders can't talk to borders, border can't talk to the master controller, whatever, we would no longer be able to actually check the quality. It is the Intelligent Path Control, it is the PFR v3 that actually sends the probe, does the reporting, does the unified monitoring. And again, as we talked before, that ISP link and you using it in a very, very large capacity when it's been sitting there as a backup for so long, that's very new. So really what I'm finding a lot of people want to do is if something happens with the Intelligent Path Control, you want to fall back to your MPLS service provider, you're tried, you're true, you're tested, where you have tight SLAs and you are still paying for those. So you fall back to whatever is in the rib. But that's the beauty of Intelligent Path Control. You can have that one entry in the rib in case you need to fall back to routing. But when the Intelligent Path Control is up and working, you can go ahead and send the business critical traffic over one way and the non-business critical traffic another way. And you can go ahead and have that world. If you're wondering a little bit about what we do over that backup channel, The business critical traffic is taken very, very seriously. What I might suggest is if DMVPN is newer to you, or you're asking yourself not necessarily why EIGRP and BGP, but what you're asking yourself is why DMVPN, I'm going to go ahead and suggest that you look here at Networking with Fish. But let's go ahead and go back to our original question. Why EIGRP? Why BGP? What does that do? How does that help with the magic here of having one entry in the rib? How did we ever even think about going over here? And why can't we do that with OSPF? Here's the beautiful thing. We want to make intelligent decisions at the WAN edge. What we don't want to do is to have 5% loss on the business critical traffic over on the MPLS and actually just go ahead and jump from the frying pan of 5% loss on the primary link into the fire of I have absolutely no idea whether or not I can even get to 172.16 from here. What do I mean by that? What I mean by that is if I only have one entry in the rib at branch 3, and that entry is to go out here to tunnel 10, how do I know at all that I can go out tunnel 20 to get to 172.16? Well, here's the beautiful thing, and also why EIGRP or BGP. Intelligent Path Control, PFR v3, can actually read the EIGRP topo table, and it can read the BGP table. It can actually make an intelligent decision at the WAN edge. If you recall correctly, branch 3 actually did have in its EIGRP topo table that it could get to 172.16.0016 out over tunnel 20. It's just that EIGRP's dual only promoted one of them into the rib. But we're making an intelligent decision at the WAN edge by knowing that we have 5% loss on the business critical link. But we also know that that DMVPN head end is actually advertising to branch 3. I can get you to this as well. And with that additional ability to be able to look in the BGP table or the EIGRP topo table, you can have the one entry in the rib and then fall back to just routing should you have a problem in your network and not be able to tell the quality of that backup link and you want to make it a backup again. OSPF, we cannot look at the OSPF database. Are we going to? If I was writing the code, I wouldn't. Why? Because it does actually get back to EIGRP and BGP do scale better. They are better solutions for larger hub and spoke type environments. And Intelligent Path Control can go ahead and go up to 2,000 branch locations. So we do want to go ahead and begin with the end in mind. So it will be EIGRP or BGP. What about static routes? Static routes actually you would also have to have 2 entries in the rivet branch 3 to get to 172.16. It is with the EIGRP or the BGP that we can go ahead and make the deeper decision and actually look at the BGP table or the EIGRP topo table. So again, that is why EIGRP or BGP over your DMVPN tunnels. If you are wondering again about why DMVPN, I will suggest that you go to Networking with Fish and look at the Business Critical Apps section. You may also want to go ahead and go back one blog to which path in the WAN are those business critical applications taking. And that will help you understand why DMVPN. So that's it. And thank you again for playing in the lab with Fish. And I hope that you had a wonderful time with IWAN and why EIGRP and DMVPN.